How's it going, everyone? This video is going to go through all of the rules of classic probability, and we're actually going to show that all of those rules, all of those shortcuts are just special cases of the general rule of classic probability. There's really only one rule, which everything else can be derived from. And as an example, we're going to do examples with the six-sided dice. As a fun fact, the opposite sides of a six-sided dice have to add up to 7, right? So if we have a 6 on the front here, the back number has to be a 1. If there's a 2 on top, the bottom number has to be a 5. And if there's a 4 on the right, the number on the left has to be a 3. That is the proper way for a dice to be designed. If the faces are not like that, if opposite sides don't add up to 7, that's actually not the correct design of a dice. So let's get to it then. The general rule of classic probability is that the probability of event A is the number of ways that A can occur divided by the total number of possible outcomes. And in classic probability, all of the possible outcomes are equally likely. So for example, on our six-sided dice, it has to be a fair dice, meaning that the way it's weighted is that you're equally likely to land on any one of the 6 sides. So here, P with an A in brackets means the probability of event A. A is just a letter we use to represent whatever event we're interested in. N next to an A in brackets is the number of ways event A can occur. And N with an S in brackets is the total number of possible outcomes. Okay, S is used here to represent the word set. Okay, so for example, on a six-sided dice, let's say X will represent the roll, and we want to know, well, what's the probability that X is greater than 4? Well, that's going to be the number of outcomes corresponding to a roll greater than 4 divided by the total number of possible outcomes. For the case of a six-sided dice, the number of outcomes greater than 4 is 2, right? You can roll a 5 or a 6, okay? Those are the only options greater than 4. And 6 is the total number of possible outcomes. So 2 out of 6, which is approximately 0.33 or 33%. More precisely, 1 out of 3. It's just 3 different ways of writing the same thing. You could say there's a 33% chance of rolling a number higher than 4, or a 1 out of 3 chance, or a probability of 0.33. Now, let's look at some special cases, okay? What's the probability that X is greater than 0? Okay, well, that's the number of outcomes where X, our roll, is greater than 0, divided by the total number of possible outcomes. Well, all of the rolls are greater than 0, right? The numbers go from 1 to 6, right? Again, the outcomes on a six-sided dice are the numbers from 1 to 6. They're all greater than 0. So 6 of the outcomes are greater than 0, and there's 6 outcomes in total, which gives us 1. Okay, and that's the first rule that we're going to put here. If the probability of an event is equal to 1, okay, that's the same as saying that event A will always happen. It doesn't matter what the outcome is, event A will always be occurring. For example, you're always going to roll a number bigger than 0 if you're rolling a six-sided dice. Now, what if we have the probability of X being greater than 7? Well, again, that's the number of outcomes greater than 7 divided by the total number of outcomes. Well, there's no outcomes greater than 7, right? Our numbers only go to 6. So 0. There's no outcomes greater than 7. There's 6 outcomes in total. 0 divided by 6 is 0. Okay, and this is an example of the next probability rule that we're going to write down. If the probability of A is equal to 0, that's the same as saying that A will never happen. Okay, the probability is 0, it just cannot occur. Now, something cannot be more likely than always happening, nor can something be less likely than never happening. So, if something always happening is a probability of 1, and that's our maximum, and something never happening is a probability of 0, and that's our minimum, what that tells you is that the probability of A will always be between 0 and 1. Okay. Now, let's do another example. What about the probability of x not being greater than 4? Okay. So, what's that? Well, that's going to be the number of ways that x is not greater than 4 divided by the total number of possible outcomes. I'm actually going to fix this slash here. There we go. Okay, well, how many numbers are not greater than 4? Well, let's look at all our possible outcomes again. Well, these ones right here, right? The numbers 1, 2, 3, and 4 are not greater than 4. All right, so 4, and the total number of 6, right? So 4 out of 6 is 0.67, or you could write that as 2/3, 2 out of 3, or you could write that as 67% approximately, right? And the decimal place is also rounded to 2 decimal places, so different ways of saying the same thing. If we stick to the decimal method, 0.67 is the probability that something is not greater than 4. But there's another way we could calculate this. We already know that the probability of x being greater than 4 is equal to 0.33. We calculated that up here, right? So, well, if there's a 33% chance of it being greater than 4, well, then there's a 67% chance, right? 100 minus 33. Well, then there's a 67% chance of it not being greater than 4, right? So we can just say, well, the probability of x not being greater than 4, that's going to be 1 minus the probability of x being greater than 4. So that's 1 minus 0.33, or 100% minus 33%, and that's going to give us 0.67, or 67%. Okay, alternatively, you can think of it as, like I said, 100% minus 33%, or you can think of it as 1 minus 1/3, and that gives you 2/3. And that brings us to our next probability rule. The probability of not A, okay, again, if we go by our general definition, it's the number of ways that not A happens, so the number of outcomes that do not correspond to A, divided by the total number of possible outcomes. Well, what are the outcomes that don't correspond to A? Well, it's going to be all the outcomes minus the ones that correspond to A. Okay? That's what the outcomes that don't correspond to A are. So what happens when we simplify this? We get NS over NS minus NA over NS. Okay, well, NS over NS, that's just a number divided by itself. Any number divided by itself is 1. As for NA divided by NS, well, that's the probability of A, right? That's just the basic definition of classic probability. Probability of A is number of ways A occurs divided by the total number of possible outcomes. So, That's just the probability of A. What do we have in summary then? The probability of not A is just equal to 1 minus the probability of A. Okay, that's our next rule that is derived here. So, for example, the probability of not rolling a 6, well, that's just 1 minus the probability of rolling a 6. What's the probability of rolling a 6? Well, that's the number of ways you can roll a 6 divided by the total number of possible outcomes. There's only one 6 on the dice, so that's going to be 1 out of 6, which comes to 5/6, right? 1 minus 1/6 is 5/6. The probability that you don't roll a 6 is 5 out of 6, which is pretty high, right? If you want that in decimal form, that's going to be 0.83 approximately. 0.83. Or 83%, right? Chances are you're not going to roll a 6. Now, let's look at another question. What about the probability of x being even or x being greater than 3? Okay. Well, by our definition of classic probability, that's going to be the number of ways that x is even or x is greater than 3 divided by the total number of possible outcomes. Now, how many ways can x be even? I'm going to write down our numbers, our possible outcomes again, right? The numbers on a 6-sided dice. Okay, so how many even numbers do we have? A 2, a 4, and a 6. Okay, so there's 3 even numbers. Okay, but also anything greater than 3 goes. How many numbers do we have greater than 3? I'm going to use a different color here. Okay, well, 4, 5, and 6 are greater than 3. Right? So, okay, there's our numbers that are greater than 3. There's another 3 of them. But here's the thing, right? We know the bottom is 6. If we do 3 plus 3 divided by 6, well, that's 6 over 6, that's 1. But certainly the probability isn't 1, right? It is possible to roll a number that is not even and not greater than 3, right? And the thing is, we have to subtract something here. And what we have to subtract is a 2. We have to subtract the overlap. Okay, if you notice, there's 2 numbers here, the 4 and the 6, they contribute to both categories. They contribute to the 3 that are even, and they contribute to the 3 that are greater than 3. So if we just add the even numbers and the numbers bigger than 3, we are double counting those cases. Those 2 cases are being double counted, and to compensate for that double counting, we have to subtract one of those double counts, so they're only counted once. And that's what gives us the right answer. Okay, so we have 3 plus 3 minus 2, which is actually a 4, divided by 6. Okay, so that's 2 out of 3, or 0.67, or 67%. Again, here the decimal is being rounded to 2 decimal places. So the general rule of probability here, so the probability of event A or event B, so that's the number of ways A or B can happen divided by the total number of possible outcomes. But what is the number of ways that A or B can happen? Well, it's the number of ways A can happen plus the number of ways B can happen. But if that's the only thing we look at, we are double counting cases where A and B happen simultaneously because they contribute to the A count and they contribute to the B count. So to compensate for that double counting, we have to subtract the double counting once, the probability of A and b. Right? So we take that, divide by the total number of possible outcomes. Now here's what happens when we simplify that. Okay? We have NA divided by NS plus NB divided by NS minus NA and B divided by NS. So by the basic probability formula, the number of ways something happens divided by the total number of outcomes, that's the probability. So our first term here, that's just the probability of A. Our second term, that's just the probability of B. And our third term, that's just the probability of A and B. Okay? So putting all that together, we have our shortcut, the probability of A or B, right? That's what we started with up here. That equals the probability of A plus the probability of B minus the probability of A and B. So as an example, okay, let's say we want the probability that X is greater than, let's go with greater than 4 or odd. Okay, so that's going to be the probability that X is greater than 4 plus the probability that X is odd minus the overlap. Okay, X greater than 4 and odd. All right, well, what's the probability that X is greater than 4? Okay, if we're dealing with the numbers 1 to 6, well, there's only two numbers greater than 4, the 5 and the 6. That's going to be 2 out of 6. What's the probability that X is odd? Well, there's 3 odd numbers, 1, 3, and 5. So 3 out of 6. And what's the overlap? How many odd numbers do we have that are greater than 4? Well, only one of them, right? The 5, because the 6 is even. So subtract 1 out of 6. And what do we get? So we have 2 sixths plus 3 sixths minus 1 sixth. That gives us 4 sixths, or 0.67 approximately. Now, if we just look at the numbers, 1, 2, 3, 4, 5, 6, how many do we have that satisfy these conditions? Greater than 4 or odd? Well, four, right? There's 4 numbers that are either greater than 4 or odd, right? So 4 out of 6 is the correct answer. So that's how that shortcut works. The remaining property we'll look at is something that has to do with conditional probability. So conditional probability, PA given B, okay, that means what is the probability of event A given, this vertical line in between means given that B already happened. Okay, so for example, the probability that X is greater than 4 given that X is even. Okay, what that means is we already know that X is even. So if X is even, okay, if we're definitely rolling an even number, what are the chances that we roll something that's greater than 4? Okay, well, what even numbers do we have? Okay, so our even numbers are 2, 4, and 6. How many of them are greater than 4? One of them, the 6. So our total number of possible outcomes is actually not 6, right? Because it's given that X is even. We're only dealing with the even numbers. So if we follow that general formula, right, the number of outcomes corresponding to what we're looking for divided by the total number of possible outcomes, we've only got 3 possible outcomes. because x has to be even, and there's only 3 even options here. Okay, so of those, how many are greater than 4? Well, one of them. Okay, so 1 out of 3, so that gives us 0.33. Okay, notice that's different than the probability of x being greater than 4 and even. Okay, here we're not setting any condition that x is definitely going to be even, right? It's not given that x is going to be even. We're looking at all the possibilities, right? So of all those 6 possibilities, how many of them are greater than 4 and even? Well, just one of them. That's 1 out of 6. Okay, or in decimal form, 0.17. That's also different than the probability of x being greater than 4 or even. Okay, how many numbers do we have that are greater than 4 or even? Well, we have all the even numbers and all the numbers greater than 4, which will include that 5. So that actually becomes 4 out of 6, or 0.67 in decimal form. Right? So this is 3 different situations. Okay. Now, so how did we get that 3? Well, it's the number of ways that our given condition can occur. And how did we get that 1? Well, it's the outcomes that correspond to our given condition and the actual final condition that we're looking for. So to generalize that, the probability of A given B, our total number of outcomes is the number of ways B occurs, because we're only considering the cases where B has already happened. And the number of outcomes corresponding to A, it's not just going to be the number of ways A can happen, it's going to be the number of ways A and B can happen. Because we're only interested in those cases of A that happen simultaneously with B. Like here, we're only interested in those numbers greater than 4 that are simultaneously even. Right? That's why we're only interested in the 1 case of the 6 and not the 5. So what I'm going to do here is I'm going to multiply this by 1. And I can do that because anything times 1 is itself. Now I'm going to rewrite that 1 as the total number of outcomes divided by the total number of outcomes, which we can do. Anything divided by itself is 1. So what we have then is something that looks like this. And because we can multiply and divide in any order, I'm actually going to take this part here. I'm going to take the number of ways A and B can happen and divide by the total number of possible outcomes. And notice that that's the probability of A and B. Okay, so this is the probability of A and B. And we still have the total number of outcomes on the top and the number of ways B occurs in the bottom, right? And that, of course, is equal to the probability of A given B. Now what I'm going to do, I'm going to rearrange this formula. Okay, this these two values here, this one and this one, I'm going to bring them to the other side of the equation. All right, so I'm going to have NB times the probability of A given B is equal to the probability of A and B times NS. And then I'm going to divide both sides by NS. And I'm going to have NB divided by NS times the probability of A given B equals the probability of A and B. And then we notice that this fraction over here, NB over NS, that's just the probability of B. The number of ways B can happen divided by the total number of possible outcomes. Right? So we can write this as the probability of B times the probability of A given B. That's equal to the probability of A and B. Okay, and that is the final rule that we're going to derive here. The probability of A and B, just rewriting it, equals the probability of B multiplied by the probability of A given B. Okay, the probability of two events occurring simultaneously is the probability of one of them occurring multiplied by the probability of the second one occurring given that the first one has occurred. Okay, they have to occur simultaneously. So for example, the probability that x is even and x is greater than 4, that's going to be the probability that x is greater than 4 multiplied by the probability that x is even given that x is greater than 4. Okay, so what's the probability that x is greater than 4? Well, there's only two outcomes on a dice that are greater than 4, the 5 and the 6. That's going to be 2 out of 6. Okay, and what's the probability that x is even given that it's greater than 4? Well, there's only two outcomes greater than 4, right? The 5 and the 6, and only one of them is even, so that's 1 out of 2. So what we have then is 2 out of 12, or 1 out of 6, or 0.17 approximately, is the probability that x is even and x is greater than 4. So that's all of our probability rules derived. And they're all just special cases of this one single formula. That's supposed to be an NA divided by NS. From that we get the probability of A and B is the probability of B times the probability of A given B. From that we get the probability of A or B is the probability of A plus the probability of B minus the overlap, probability of A and B. We also get that the probability of not A is equal to 1 minus the probability of A. We get that the probability of A must be between 0 and 1. And we also get that the probability of A being 0 is like saying A is impossible, and the probability of A being 1 is the same as saying A is always the case. So, I hope you enjoyed that and that was helpful, and until next time.